The next stage or step you can do in trigonometry, if you can't use right-angled easy steps, for example, Pythagoras' theorem, or your sine, cos, and tan ratio, is you can use the sine rule. Right? For the sine rule, you will need a triangle where you need to know the length of a side and its opposite angle. It doesn't have to be a right angle triangle, so it can be any triangle. It can be right angled or it cannot be right angled. It does not matter. It just has to be a triangle. So in terms of our scalene triangle here, or our basic triangle, if this is the angle, the side which is across from it and not touching is its opposite. So you have angle, opposite, angle, opposite, angle, opposite. Right? If you're unsure of what to do, go to the vertex or go to the corner of your triangle and draw a line down, and whatever line you crash into that is not in actual contact with the corner is its opposite. Right, so in terms of the sine rule, if you're looking for an angle, right, you put the sine of the angle you're looking for over its opposite side's length equal to the sine of a known angle over the known opposite side to this angle. Okay, so when you're maneuvering the formula or multiplying it out, we leave the sine of the angle up here, but we move the opposite side across the equal sign. So when it's moving across, it was dividing, so now it's going to multiply the top. So we would have sine of the known angle times the opposite side over the known opposite side. In terms of the top here, right, make sure on your calculator when you're plugging it in that you know it's the opposite side times the whole sine of the known angle, not the sine of the known times the opposite, if you get what I'm saying. So if this was, say, 10, and this was sine of 50, it is not the sine of 500. It is 10 times the sine of 50, right? And then the final step is we don't want the sine of the angle. You want the angle itself. So you are going to get rid of the sine from this side of the equal sign. How you do that is you bring it over and you invert it, so you get sine minus 1. So you get the sine minus 1 of everything that was on this side of the equal sign. So you're getting sine minus 1 of the opposite side times the sine of the known angle divided by the known opposite side. Okay, and that's if we are looking for an angle. So if you have your book, right, text and text, you're on page 408, right? There's examples there to do with finding the measure of angles, right? So in terms of these, you have triangles. You can see them properly, right? You have triangles. In terms of the triangles, they're not necessarily right angle triangles. In fact, none of these are. And how we know that is they have no right angle signals or symbols. So how you solve them is in the question, you know that you have to get an angle. All right, so the first one here, we are looking for the angle A. So you look at the triangle, you go, it's not a right angle triangle. You look and you see, have you a side and its opposite angle? So we have this side and we have this opposite angle. So we have a side and an opposite angle. Okay, for the angle we're looking for, we have its opposite side. So we are looking for an angle, so your formula will be the sine of the angle over its opposite length is equal to the known angle's sine over the opposite length. Excuse my bad writing. All right, so in terms of this, we are looking for the sine of A. So you put sine of A over its opposite, which is 11, equal to the sine of the known angle. So we're going sine 66 over its opposite, which is 18. Okay. Now what we want to do is we want to get this A all on its own. So at present, it's been divided by 11 and it's been multiplied or worked on by a sine. So we want to move both of those. So the easiest thing to do is move the 11 first. So take it in steps. So you go sine A is 11 times sine 66 over 18. So it was below the equal sign. So when it came across the equal sign, it went above. Right? We still have sine of a. We want a in its own. So a is equal to sine minus 1, or the inverse sine, of 11 sine 66 over 18. Right? So for that one, what you do is you get your calculator. Right? You go the shift button, the sin button, so you're getting sine minus 1, or your sine inverse. Brackets, 11 sin 66. Close your bracket because on the calculator it left out the bracket here. All divided by 18. Close your bracket. Equals. And it tells us minus 0.0162. So I think I have done something wrong. So if I check my calculator work, I go, if I work out the bit in the middle first, so if I go 11 sin 66 equals, divide by 18 equals, so this is what this bit was. It wasn't working out sine minus, and then I get the inverse sine of it. I'm still getting the same answer, so I have done something wrong. So we'll pause that for a second and I'll work out what I've done wrong. Okay, I'm back. I have discovered what I did wrong. As in, when I look at this, I know I've done something wrong because it's giving me a minus decimal for an angle. Okay, I can't have minus decimals for an angle. So when I look at my calculator, it's a very common thing that happens, is at the top here, it has a little or. I do not want it to be in ors. I want it to be in degrees. All right, so the problem is that my calculator is in the wrong setup. I need it to be in degrees. So what you do is you press buttons around and it should work. So if I go to my shift button and this degree, I have the choice of degrees, radians, or gradients. I want it in degrees, so I go 1. So now my little sign at the top should have changed, but it didn't. Crap. So back to pausing again, and I will be back again in a second. Okay, so back again. Eventually I've discovered what I'm doing wrong. Right, so to get it to change from your radians to degrees, you go shift, setup, and then you press 3 here. So when you press 3 here, this little thing at the top changes to a D. So now if we have our sum and we plug in what we had, so we have shift sine minus 1. Let me move over so you can see what I'm doing. Shift sine minus 1 bracket, 11 sin 66, close your bracket, divide it all by 18, another bracket, equals, and it tells you got 33.93, which is much more what we'd want. So we do not want a minus number or a decimal, tiny decimal. So this is telling us that we've got 33.93 degrees, which is roughly the same as 34 degrees. Okay, so if you try this one. Okay, so you've got a triangle. We have B across from 16, and we have 26 across from 9. So work out what B is.